Hello and welcome. I'm your host, Adam Hawkins. Each episode, I share a small batch of software engineering theory and best practices. If you enjoy this podcast, then please subscribe and share it with your friends and colleagues. Hey everyone, welcome to the next episode of Small Batches. It's me, Adam Hawkins, coming to you from sunny and warm Hawaii. Just like all of us, I'm quarantined inside, so there's not that much else for me to do besides look out my window and ponder the craft of software engineering. As a result, this episode is longer than usual, so nurse that coffee while I serve up a small batch of software engineering theory and best practices. Today's topic is 12-factor apps. The 12-factor app describes how to build software for deployment pipelines. These guidelines make software easier to run in development, staging, production, and any future environment. Heroku members wrote the 12-factor app back in 2012. The authors tried to enumerate best practices for running applications on their platform. These guidelines were especially helpful since they coincided with an industry shift towards DevOps, microservices, and continuous delivery. 12-factor app guidelines are still relevant today since many teams are building distributed systems which require careful attention to detail as to how services are coupled, configured, and deployed. The 12-factor app is a wonderful starting point for best practices. In my experience, though, they omit a few facets and leave room for anti-patterns in certain facets. My goal with this podcast is to share knowledge and practices for building, deploying, and operating software. The 12-factor app triangulates all three of these areas. This is partially why I love the 12-factor app so much. It's a rare piece of work that hits on so many themes of this podcast. So in this episode, let's review the 12-factor app and flag future discussion points. Codebase, the first factor, defines the relation between code, apps, and deployments. The gist here is that a single codebase, i.e. a Git repo, equates to a single deployed app or service. Different versions of a codebase may be deployed to different environments. So this implies that if there are multiple code bases, it's not an app. It's a distributed system. Each component in a distributed system is also an app, which should also comply with 12-factor guidelines. Let's flag this for future episodes since we need to adopt a distributed systems first perspective instead of the other way around. Dependencies, the second factor, states a 12-factor app never relies on system-wide packages. Instead, apps must leverage tools like Ruby's bundler or Python's virtual env to manage their own dependencies. This is where the second factor ends. Separating out application dependencies is only part of the problem. You must also isolate the app's runtime. Admittedly, this is more relevant for Ruby, Python, or Node.js apps which rely on managed runtimes. The sticking point is the same for statically compiled applications. For example, they might be written in Go. Now, just to reiterate, the quote dependencies factor focuses on application dependencies rather than application runtimes or execution environments. So where do those come from? And what can deployment pipelines expect from dependencies? Let's flag this for future episodes. Config, the third factor, states that the application should read configuration from environment variables. Now this makes it possible to deploy changes to production without altering code. That's good. A litmus test for whether an app has all config correctly factored out of the code is whether the code base could be made open source at any moment without compromising any credentials. Separating config and code is a great starting point, but just not enough. Personally, I find the third factor the most wanting. There are great ways to work with config and also horrible anti-patterns. Neither are discussed in the third factor. Let's stick a big flag in this factor for discussion in future episodes. Backing services, the fourth factor, states applications make no distinction between local and third-party services. Now, for example, an application's database and connection to external APIs should be treated in the same way. The idea promotes loose coupling between apps and services. The 12-factor app uses an example of switching a local SMTP service for a third-party service with only config changes and no code changes. Again, this is a good starting point, but requires some clarification and amendments to the config factor and also the future dev prod parity factor. Build, release, run, or the fifth factor, states apps use strict separation between the build, run, and release stages. The build stage converts code into an executable. The release stage combines the executable and config into something runnable. In other words, a deploy is the combination of code and config. It's not possible to change one without creating a new release. Processes, the sixth factor, states apps execute as one or more stateless processes using a shared nothing architecture. If data needs to persist across restarts or releases, then it must be stored in a stateful backing service such as a database. I like this factor because it surfaces the idea that apps are composed of multiple processes such as a web server, maybe a background job worker, or a cron process. This model scales up to distributed systems, which are composed of multiple apps interacting across various processes. This factor also implies the deployment pipeline must handle that releases contain one to n processes which may require different semantics. In other words, the deployment pipeline cannot assume a single process or process type. Port binding, the seventh factor, states an app is completely self-contained and exposes itself through ports. This seems obvious, but it's a good architectural principle to state out loud. Given services are exposed through ports, then it's possible to configure others by providing the hostname and port of the relevant process. Processes, the eighth factor, state that processes are a first-class citizen. The stateless shared nothing model naturally promotes horizontal scaling. Just start more processes. You can scale vertically by allocating more compute or memory resources to processes that need it. The corollary here is that processes should never daemonize or write PID files. Instead, they are controlled by a process manager like systemd. In other words, write your app such that it starts processes in the foreground and use a process manager to scale, start, and stop processes. Disposability, the ninth factor, states processes should be ready to start or stop at a moment's notice. Fast startup times encourage smooth scaling. Conversely, processes must gracefully handle the SIG term signal. Servers should stop listening on the relevant port, finish processing any requests, then exit. This approach ensures new releases or other infrastructure events do not impact user-facing requests. DevProd parity, or the 10th factor, states that apps are designed for continuous deployment by minimizing the gap between development and production. The original guideline states, the 12-factor developer resists the urge to use different backing services between development and production. I think this makes sense when applied to databases, but has negative implications when applied to distributed systems. Does this mean a development environment for one service in a large distributed system mandates running all other services? Well, if you're targeting DevProd parity, then the answer may be yes. However, answering yes is not always practical. Consider the case where the system in question is a single service. Then it's simple enough to achieve DevProd parity. Now let's scale that up. What about DevProd parity when there's 5 services, 10, 20? What about 100? Now the 10th factor offers no advice or guidelines for how to handle inflection points as the system grows or which degrees of DevProd parity to consider. Logs, the 11th factor, state that apps never concern itself with routing or storage of its output stream. Instead, all output should be sent unbuffered to standard out. This works well in development because developers can see output in their terminal. It also works well in production since tools can capture output streams for analytics and storage. Again, the 11th factor is a wonderful starting point but needs to be improved upon for continuous delivery and production operations. The 11th factor does not cover what or how things should be logged. In fact, this is the only mention of telemetry, a vital facet of continuous deployment largely uncovered by the 12-factor app. Admin processes, the 12th factor, state that admin work such as migrating databases or other out-of-band work executes as a separate process. Processes may be started using the same release, meaning the same config and code. Now, I don't have much to say about this factor, so let's put a pin in it and wrap up. Future episodes will dive deeper into the individual factors with the focus on identifying and closing the gaps. My biggest gripe with the 12-factor app is around the config and DevProd factors and the overall omission of anything telemetry and metrics related. I'm curious about your experience with 12-factor apps. How has it worked out for you? What do you think is missing? Where do you think it could be improved? Please send your comments to hi@smallbatches.fm. Also, feel free to tell me what you want covered in future episodes, so I have something to do while we're quarantined. Well, with that, I leave you to it. Good luck out there, and happy shipping. Want to learn more about DevOps but don't have time for books? Then sign up for my free email course at freedevopscourse.com. The course details the 3 ways in depth, along with continuous delivery, trunk-based development, and much more over the course of 9 days. Sign up now at freedevopscourse.com.